students, welcome to our today's lesson. It's about separation of solid liquid mixtures. Now there are two types of solid liquid mixtures, which include the soluble solid liquid mixtures. Now these are mixtures whereby the solid dissolves completely into the liquid, and a good example is the mixture of salt and water. Now the other category is the one for an insoluble solid liquid mixture, and here is a situation whereby the solid does not dissolve in the liquid. A good example of such is a mixture of sand and water. Now let's move on to discuss about soluble solid liquid mixtures. Now here the solid dissolves into the liquid, and it can be the mixture can be separated by the following methods. One, it can be separated by evaporation. It can be separated by crystallization and simple distillation. Now we are going to discuss each one of these methods, and we begin with simple distillation. Now, simple distillation separates a mixture of a solute and a solvent, for example, sodium chloride solution. Now, sodium chloride solution is a mixture of sodium, chloride, and water. So, in order to be able to separate the sodium chloride, which is common salt, and water, then we use the method of simple distillation. The diagram of simple distillation is shown below. So the simple distillation setup is as shown above, whereby the salt solution is heated in the round bottomed flask. The water in the solution evaporates, and it is cooled by the Liebig's condenser to form liquid water, which is then collected as a distillate. You are able to see that from the diagram. The sodium chloride remains in the round bottomed flask as a white solid. This simple distillation process is mainly used for the purification of liquids containing dissolved substances, the separation of two miscible liquids with very wide differences in boiling points. So those are some of the uses of simple distillation. Then we have the Liebig's condenser, which is used to condense the vapor to a liquid. Now, on the Liebig's condenser, the water in, you see that part written water in, that is where the cold water from the tap enters into the Liebig's condenser so that it can be able to condense the vapor into a liquid. So that water in is on the lower part of the condenser, while the same water leaves through the water out, which is on the upper part of the condenser. Now this is done to ensure that there is efficient condensation. In other words, the water has enough time climbing up the Liebig's condenser against gravity before it leaves on that upper part where the water goes out. Now, if the water in and water out were interchanged, then the condensation would take place but not efficiently. Because you see, from the water in, the water would just pass very fast to the water out due to gravity. Therefore, the condensation wouldn't be as efficient as in the case on the setup. Yeah, some of the applications of simple distillation include production of distilled water. The water we normally use in the laboratory for various experiments is normally distilled water. So it's normally produced through simple distillation. Then we also have production of bottled pure water. This water we use at home for drinking. The one we usually buy from the shop, the supermarket, and so on and so forth. Now such, we call it mineral water, is normally produced through simple distillation. Then we have desalinization of seawater to obtain pure water. Now this is whereby the seawater is salty. So the salt is normally removed from the seawater through simple distillation, and we are able to obtain pure water. And finally, simple distillation is used in the manufacture of wines and spirits. The next method we are going to look at is crystallization. Now, crystallization is a method used to obtain a solute from a solution, whereby the solution is heated to evaporate water and form a saturated solution, and then the saturated solution is allowed to cool in order to form crystals. An example is when we want to obtain copper 2 sulfate crystals from copper 2 sulfate solution. Now what happens here is we place the copper 2 sulfate solution in a evaporating dish, and then we place it on a water bath so that the excess water in the solution evaporates, and when the solution is saturated, then we allow it to form so that we are able to allow it to cool so as to obtain crystals of copper 2 sulfate. A saturated solution is a solution that contains the maximum amount of a solute at a particular temperature. In other words, it cannot absorb any more solute at that particular temperature. Then crystallization is the process of obtaining crystals from a saturated solution. Let us talk about fractional crystallization, which is under crystallization. Now this is a method used to obtain two different solutes with different solubilities from the same solution. For example, to separate sodium chloride and trona from Lake Magadi, we use fractional crystallization, whereby the two different solutes crystallize at different temperatures because their solubilities are different at different temperatures. So this one will be covered in details in book 4, but for now let's just understand that fractional crystallization is a method of obtaining two different solutes from a solution, and it is based on their differences in solubilities in that solution at different temperatures. Applicable in the extraction of sugar from sugar canes. So the process by which the juice is squeezed from sugar cane, then of course it's evaporated for excess water to leave, then finally crystals of sugar are formed. So that is crystallization. Then we also have it used in the extraction of medicinal substances. Now most of the medicinal substances are plants. So what happens is that the plant leaves, branches, or even roots are crushed. Then after crushing, they are evaporated so that excess solvent, the solvent used evaporates until they are saturated. And from there now, you can be able to form the medicine in tablet form, in crystal form, some of it in syrup form, and so on and so forth. So that process of extracting the medicinal substances involves some crystallization in it. The next method of separating soluble solid liquid mixtures is evaporation. And evaporation is normally used when you want to obtain a solute from a solution. So in this case, you don't want the solvent. Instead, you just want the solute. For example, if you want to obtain salt from a solution of sodium chloride. So in this method, the mixture is heated to evaporate the solvent. Solute is left as a residue in the evaporating dish. The evaporating dish is heated using a water bath so that the salt does not spit out of the basin as heating continues. So that is the reason why we use the water bath, so that the salt does not spit out during heating. So this process is used to obtain salt from seawater. Now we have a setup for evaporation there, whereby you see the evaporating dish where the solution being evaporated is placed. Then we have water in a beaker which forms the water bath, and heating takes place at the bottom there. So the tripod stand and the wire gauge hold the setup in position for the evaporation process to take place. Now, in summary, we have been able to talk about the methods which are used to separate solid liquid mixtures, which include simple distillation, we have crystallization, and we have evaporation. So with the discussion we just had, I would like to give you some questions which you might use to evaluate yourself. The first question: describe how you would separate a mixture of salt and water. Question number 2: explain the method used to separate soluble substances from their solution. Question number 3: explain the method used to separate a solvent from a solution. Explain the method used to separate a solvent from a solution. Question number 4: state 3 applications of fractional crystallization. State 3 applications of fractional crystallization. Then question number 5: brine is made by mixing water and common salt. Brine is made by mixing water and common salt. Name the solute and the solvent. Name the solute and the solvent. Now that is the end of our lesson today. In our next lesson, we shall look at the separation of insoluble solid liquid mixtures. Till then, enjoy yourselves and have a nice time.